So imagine you're spending, I don't know, thousands of hours building this incredibly intricate machine from scratch right in your garage.
Oh, wow. Okay, setting the scene.
Yeah, like a total passion project. You are fabricating every single gear, you're soldering every wire, mapping out the whole schematic in your head.
Right, very meticulous work.
Exactly. And then you reach, say, step 164 of the process, and you suddenly realize that this highly specialized custom bracket you just spent 3 entire days designing.
Oh, no. I think I know where this is going.
You probably do. You realize it could have just been bought at the local hardware store for like $1. It was literally sitting on the shelf the entire time.
That is, that's just the absolute worst feeling. But honestly, it happens so often in engineering.
It really does. And today we're actually looking at a highly specific, curiously titled blog post that captures that exact feeling. It's from this deep dive we're doing into a post called Notes on Haskell Programming, Part 164, on using Data.Set.member.
Yeah, by a developer named Ang, published on June 17th, 2026.
Right. Which, just by the title alone.
It sounds incredibly dry.
Yeah.
Very dry.
It's the kind of title that usually guarantees this purely clinical read,
Yeah.
You'd expect to find a list of syntax changes or a really technical breakdown of, compiler optimization. But discovering this post actually felt like cracking open a dusty engine manual and finding this deeply personal, slightly exhausted diary entry just slipped right between the pages.
Which is exactly the mission for our deep dive today. We really want to read that diary entry. Because on the surface, yes, we are looking at a single code update about optimizing membership checks in the Haskell programming language.
Right, standard refactoring stuff.
But if we actually unpack the mechanisms behind the code and the commentary surrounding it, we get this fascinating, completely unfiltered snapshot of solo development.
Yeah, the real human side of it.
Exactly. We're talking about the reality of managing a passion project, the physical toll of time constraints, and, well, a very human rebellion against artificial intelligence, which completely shatters that illusion we often have about software development.
Oh, completely.
Because we tend to view code as this sterile mathematical architecture that just springs into existence perfectly formed,
Like it was handed down on stone tablets.
Right, exactly. But a project that has reached part 164, that is a living record of someone's thought process. It includes their blind spots, their dead ends, and honestly, their eventual burnout.
So true. So before we can fully appreciate that human drama in the final paragraphs, we really have to understand the technical trigger that prompted Ang to even sit down and write this update in the first place.
The catalyst, yeah.
Right. The post starts off discussing a refactoring phase. Ang is tightening up the code, they're adding test cases, and implementing this seemingly minor optimization. They're using a module called Data.Set and a specific function within it called member.
Yeah, and to understand why this is a significant moment for the developer, we kind of need to look at the mechanical difference between how a computer searches through a standard list versus a set.
Okay, lay it on us.
Well, when you tell a program to find an item in a standard list, it basically operates sequentially.
One by one.
Exactly. It looks at the first item, asks, is this it? Moves to the second, asks again, and so on. So if you have 10,000 items and the one you actually want is at the very end, the computer has to perform 10,000 distinct checks.
I mean, it's like trying to find a specific person in a phone book, but instead of jumping to their last name, you just start on page 1 and read every single entry until you hit the one you want.
That is the perfect analogy. It's just an algorithmic nightmare for performance.
Yeah.
A set, on the other hand, is a collection of unique items that is optimized specifically for lookup speed. Under the hood, sets in languages like Haskell are often implemented as balanced binary search trees.
Okay, balanced binary search trees.
I know, it sounds intense, but without getting lost in the computer science weeds, this basically means the data is structured so that with every single check, the computer eliminates half of the remaining options.
Oh, wow. Half of them instantly.
Right, so finding an item among 10,000 doesn't take 10,000 steps anymore. It takes maybe 14.
That is a massive difference. And the member function is simply the command that triggers that lightning-fast lookup, right?
Exactly. You hand it an element, and it instantly verifies if it exists in the collection.
Which makes Ang's admission in this post absolutely wild to me.
Oh, the confession.
Yes. They write, and I'm quoting here, I've noticed that I've never used the containers package that came with the standard Haskell distribution before.
Yeah, it's just a stunning confession for someone at part 164 of a deeply technical blog series.
I mean, wait, really?
Yeah. The containers package, which houses Data.Set, is completely foundational. It literally ships with the compiler itself.
See, I'm trying to wrap my head around how that even happens.
Yeah.
Like, does a programmer really get that deep into building a complex software ecosystem without ever reaching for the standard tools?
You'd be surprised.
Is that just the reality of tunnel vision when you're, like, inventing the logic from the ground up?
It really is. It happens far more often than textbook computer science courses would ever have you believe.
Really?
Yeah, because when you are the sole architect of a complex system, your cognitive load is entirely dedicated to the unique problem you are trying to solve in that exact moment.
You're just trying to survive the current task.
Right. You are laying the track mere inches in front of the moving train. So if you need a way to check a list of items, you might just write a quick custom function to iterate over a standard list because, well, it solves the immediate problem in front of you.
And you don't want to break your flow.
Exactly. You don't pause your entire train of thought to go browse the documentation of standard libraries.
Because the custom function technically works.
It works.
It might be slow. It might be the equivalent of reading the phone book line by line, like we said, but it gets the job done for the first 163 iterations of the project.
Mm-hmm. And that context is exactly what makes the code diffs, ang, shares, and the posts so revealing.
The diffs being the actual changes to the code files.
Right, the before and after. We see these additions to the package.yaml file, bringing in dependencies like hspec, megaparsec, and bytestring.
Okay, so bunch of testing stuff.
Exactly. These are not libraries you use to build flashy new user-facing features. hspec specifically is a behavioral testing framework.
So it's just for making sure things don't break.
Purely. It exists only to write automated tests that verify your code behaves the way you expect it to.
So this represents like a massive psychological shift for the developer then.
Huge.
They've stopped moving forward. They've essentially stopped building the track. They're now going back over the miles of track they already laid down, testing every single bolt, and realizing, oh, I built all these custom brackets when I could have just used the standard data set.
Right.
It's a phase of consolidation.
Yeah, and bringing in hspec specifically means they are locking down the behavior of their application. They want to ensure that as they swap out their clunky custom lists for these lightning-fast sets, they don't accidentally break the core logic of the program.
Well, let's actually look at that core logic for a second, because the code imports ang shares are basically a breadcrumb trail.
They really are.
We can reverse engineer what this entire massive pet Haskell project actually does just by looking at the variable names. It's like finding a box of highly specialized gears and trying to guess what kind of clock they came from.
It's true. The names developers choose for their functions are, honestly, the most honest documentation you will ever find.
Total.
What specifically stood out to you in that test file, the lexiconspec.hs file?
Oh man, okay. So ang is pulling a bunch of highly specific functions from a module named xs2ebook.lexicon.
Okay.
And here is the list. Ready?
Let's hear it.
Chapter units. Chinese numeral set. Is Chinese numeral or digit. Is prose punctuation. Keyword headers. Volume units. And year 2 Chinese.
Wow.
I know. We don't have the marketing pitch for this software anywhere, but those names paint a really vivid picture.
They reveal an incredibly ambitious text processing engine. Like, the module name x2ebook strongly implies it takes some undefined input, the x's, and compiles it into a structured electronic book format.
Right.
But it's the granularity of those functions that tells us the true scale of the challenge here.
Yeah, because it's clearly not just converting a standard English text file into a PDF.
Not at all.
Functions like is Chinese numeral or digit and year to Chinese mean this software is deeply enmeshed in parsing and translating Chinese character sets. And doing that requires, I imagine, an enormous amount of computational heavy lifting.
Oh, massive amounts. And to understand the mechanics of why that is so difficult, we really have to look at how computers handle text in general.
Okay, break it down for us.
So a machine only understands binary numbers, right? Zeros and ones.
Right.
To represent a character, it uses an encoding standard like Unicode, where every letter, symbol, and character on Earth gets a very specific numerical value. When you are parsing English, distinguishing a number from a letter is relatively trivial. But parsing Chinese text, especially older or complex documents that might be getting digitized into an ebook, it is just a minefield of context.
Because you're dealing with thousands upon thousands of distinct characters.
Tens of thousands, yes.
And you have to literally teach the computer how to categorize every single one of them. Like, is this specific Unicode value a punctuation mark? Is it a number? Is it part of a volume header?
That is precisely where the dataset module becomes so critical to this project, Think about the test block Ang includes in the post. Describe Chinese numeral set do.
Yeah.
They are essentially defining an exhaustive mathematical set of every single Chinese numeral.
Mm.
So whenever the parser encounters a new character in the text, it uses that member function we talked about to check that set.
And because it's using a set instead of a list, it doesn't have to check the new character against every single numeral one by one.
Exactly.
It uses that binary search tree to instantly verify if it's a match.
Yeah.
I mean, if you're processing a 500-page ebook, that optimization has to be the difference between the software running in 3 seconds versus, like, locking up your computer for 10 minutes.
It absolutely is. And it also highlights the staggering meticulousness required for a solo developer.
Oh, I can't even imagine.
You are manually categorizing chapter units and volume units. You are defining the architectural rules of a book so the parser knows when one section ends and another begins. It is just exhausting microscopic work.
Which honestly provides the perfect psychological backdrop for the final paragraph of Ang's post.
The shift in tone.
Yeah, because once you realize the sheer scale of building a Chinese text-to-ebook parser completely from scratch, character by character, you really understand why the tone of the diary entry suddenly shifts so hard.
Mm-hmm.
We move from the sterile mechanics of Haskell testing frameworks directly into the harsh realities of human limitation.
Yeah, the developer states very plainly that recent updates have focused entirely on refactoring rather than new discoveries, simply because the project has reached what they call its necessary basic feature set.
Necessary basic feature set. That phrase just feels so loaded to me.
Well, it does.
It's like, it's the plateau of good enough. The parser works. It identifies the numerals. It formats the chapters. It outputs the ebook. But then Ang immediately follows that milestone with a dose of really harsh reality.
Yeah, admitting they lack the time and health to work on any major changes moving forward.
It's brutal. It just strips away the myth of the tireless coder working seamlessly through the night, fueled by energy drinks.
Right. Software is inextricably bound to the biological limits of its creator.
Yeah.
You can build the most elegant binary search trees in the world, but if your wrists ache or your eyes are strained or you simply have to go to your day job,
The code stops growing.
the code starts. The project enters a state of maintenance simply because the human engine has run out of fuel.
And that brings us to what I think is the most fascinating, provocative sentence in the entire post. Because we exist in a moment where the proposed solution to an empty human fuel tank is always artificial intelligence.
Oh, inevitably.
Right. If you don't have the time or health to write the code, you just prompt an LLM to do it for you. And Ang explicitly mentions trying this. They actually used AI to suggest changes to push the project forward.
But the result wasn't some huge triumph of automation.
No.
Ang writes, even with the help of AI, the suggested changes are not to my liking.
Not to my liking. I just love that phrase. That is such a subjective, almost artistic critique of purely functional code.
It really is.
Like if the AI spits out a Haskell function that successfully parses a Chinese numeral and it passes all those HSpec tests Ang just spent weeks writing, why reject it? What does it actually mean for code to be functionally correct but stylistically offensive?
Well, I think it reveals a fundamental disconnect between how artificial intelligence solves a problem and how a human craftsman approaches an architecture they have basically lived inside for 164 iterations.
Right, they know every corner of it.
Exactly. AI, particularly large language models, operates probabilistically. It looks at the prompt, scours its massive training data, and generates the most statistically average, efficient solution. It just brute forces the logic.
But Haskell developers are famously particular about the elegance of their code.
Very much so.
Haskell is a purely functional language.
Yeah.
It's built on mathematical purity and really concise abstractions. I imagine bringing average brute force AI code into a carefully manicured Haskell project feels like, well, slapping a mass-produced plastic bumper onto a meticulously restored vintage car.
That's exactly it. The AI lacks the localized context of the creator's philosophy.
Yeah.
Over the course of 163 previous posts, Ang has developed a very specific dialect within this codebase. They have a preferred way of handling errors, a specific rhythm to how they name variables, a distinct approach to abstracting the logic.
The AI doesn't care about the feng shui of the code base.
Not at all. It only cares about the output.
It's honestly the ghostwriter dilemma.
Oh, that's a good way to put it.
Imagine you've spent 5 years writing a deeply personal novel. You get tired, your health is failing, so you hire a ghostwriter to just finish the last chapter. They hand it back, and the plot resolves perfectly, the grammar is flawless, but the voice is just entirely wrong.
The characters sound different.
Exactly. The characters use words they would never use. The pacing is jarring. You read it and have to say, well, the story is finished, but this isn't my book anymore.
And for a solo developer managing a pet project, the code base is essentially an extension of their own mind. Accepting code that is not to their liking is kind of a violation of that mental space.
Yeah.
Because if the goal was simply to have a working ebook parser, Aang would have accepted the AI's pull request, merged the code, and just moved on with their life.
But the fact that they didn't, the fact that they chose to let the project sit at its necessary basic feature set rather than let a machine compromise its internal style, that's a radical assertion of the human element in programming.
It really is. The joy is clearly in the craft for them, not just the utility of the final tool.
And Aang accepts this tension quite peacefully, too. The post ends with the sentence, "We'll see how this goes in the coming days."
Just a calm acceptance.
Yeah. There is no panic about falling behind. There's simply an acceptance of the slow, methodical, deeply idiosyncratic pace of human development.
So if we look back at the incredible arc we just traced today,
It's been quite a journey.
it has. We started with the smallest possible technical footprint, right? A developer pulling the dataset module into a Haskell file just to use the member function.
Right. And then we examine the mechanical necessity of that shift, exploring how binary search trees rescue a program from the algorithmic doom of sequential list checking.
And from there, we got to play digital detective with the test imports, reverse engineering a highly complex parser forced to categorize the intricate Unicode landscape of Chinese numerals and volume headers.
It's wild. And we ended up staring down the biological limits of the developer themselves, culminating in this stubborn, honestly beautiful refusal to let an AI ghostwrite the final chapters of a 164-part passion project.
Because the underlying lesson here applies far beyond the Haskell ecosystem.
Oh, totally.
Whether you are building an intricate software tool, designing a physical product, or even just trying to organize a massive personal database, you are going to experience the friction of the Part 164 realization.
You absolutely will.
You'll discover optimizations you should have made on day one. You'll hit a plateau where your ambition just exceeds your physical energy.
And you will face the temptation to let an automated tool finish the job for you, even if it compromises the aesthetic of what you built. And honestly, this deep dive is permission to reject that compromise. It's a reminder that knowing when a project has reached its necessary basic features and having the wisdom to pause and maintain it rather than relentlessly pushing forward is how you survive the marathon of creation.
Because code is not just a mechanism for the computer, right? It is a medium of expression for the author.
Beautifully said. So I want to leave you with one final thought to mull over today. Something that kind of challenges our modern obsession with hyperproductivity.
Let's hear it.
If an artificial intelligence can write the perfectly efficient code necessary to finalize your project, but you reject it simply because the style violates your personal taste, does the true value of your work actually lie in the finished product? Or does the value exist entirely in the messy, limited, fundamentally human act of building it exactly the way you want?
That is a question every creator has to answer for themselves.
Until next time.